All right, let us continue with example or lesson 3.5 on graphing square root and cube root functions. And now we're going to take a look at a word problem. So it tells us that the period of a pendulum can be modeled by t is equal to 1 34/100 times the square root of L, where L is the length of the pendulum in feet. So using a graphing calculator, we're going to figure out how long the pendulum has to be in order to have a period, t. Period is the amount of time it takes to complete one circuit. Now, to kind of visualize what a pendulum is, imagine you're holding a pocket watch, and it's, you got a watch here, and it's swinging back and forth, like you're trying to hypnotize somebody. That is called a pendulum, when you have a fixed point, and then it's swinging back and forth. This movement back and forth, when I go from one end to the other end, is considered one period. And so we want to know what is the length of the pendulum to equal that period. So here's our function. Plug it into our calculator. So y is equal to 1.34 times the square root of x. Notice that it wants us to change our window so that x is between 0 and 3, and y is also between 0 and 3. And then we're trying to figure out the length. So by looking at the t value, well, x is representing the length, y is representing the t value. So we want to trace our graph until we get to that t value of 2 seconds. Then look at the corresponding x value to tell us what the dimension was. How long was this? So we can see from our example, it's approximately 2.23 feet long. Alright, example 4, graphing a translated cube root. Now remember in the first video I told you that we were going to come back to the basic function. We have the parent function of the cube root. Oops. Let's move that back up to where it's supposed to be. Get over here to the pen. So we have the cube root function. And then if I make some adjustments, I can change the amplitude of that. Now, A gives me how wide or narrow the graph is going to be. H tells me how far left or right to move it. So that's a good way to recognize horizontal movement. H for horizontal, H for movement. K, unfortunately there's no nice little trick there, but K tells us how far up or down. So if H is positive, we're going to move to the right, and if H is negative, we would move it to the left. If K is positive, we're going to move it up, and if K is negative, we move the graph down. So let's take a look at our graph that we got going on over here. We have negative, so normally a positive cube root would go this way. So a negative cube root is going to go the other direction, like that. As x gets bigger, y gets negative, and as x gets negative, y gets positive. It's going to have the opposite. We notice that we're adding 2, so that means h is equal to -2, and then k is equal to +1. So if I go to my normal graph, let's do this in blue. This is my basic parent graph. The origin is here, of course, at 0, 0, and then the cube root of 1 would be, we want -1 since this is kind of looking at the negative cube root. So that would be down here, and then the cube root of -1, the opposite of that would be +1. So now we're taking those 3 points and we're adjusting them with these translations. So if h is negative, it tells me to move to the left 2 units. Let's go ahead and change the color of the pen, maybe make it a little bit easier to see here. So I'm going to take the origin and I'm going to move 2 units to the left, so 1, 2, and then I'm going to move 1 unit up. Well, notice that that point is now here. I'm going to take this -1, sorry, this +1, -1 point here, and I'm going to move it 2 units to the left and up 1, and notice there's my new point. So the twisting part is happening right there, and then I'm going to take this point right here, move it 2 units to the left and up 1. So looking at just the translations, I'm not really having to make a whole new table and chart. I just go with the original easy ones to do, the cube root of 1, the cube root of 0, and then adjust those points. Translate them by moving them left or right and moving them up or down. In this case, we move 2 units to the left and up 1 unit. So sometimes the graphing can be a little bit easier if you look at it like that. Or you can always just pick some values, plug them in, and see what happens with the graph. But it's nice to know where that twist happens. Alright, so 3 more practice problems. Rework example 3 with the pendulum to find what the length has to be in order to have a period of 3 seconds, and then graph the 2 new functions and take a look at what's going to happen to the domain and range. Pause for as long as necessary, and then move on when you're ready to see the answers. Alright, and here are your answers. Be sure to mark any that you have questions on, and we will cover them in class.